propagation. What is this? There's a string itself. When there's no wave propagation, and this is called like a rigid end. This is like a wall. So what I do, I'll take a rope. One nail will be there, and the nail will be drilled in a wall. So this is like a wall. I'm interested in this particular point P. So how to, what is the reflection? So this wall is there. Let's come to the theoretical ideas later on. Just a very practical, no? You can take a rope. So all of you will be having a window frame. A grill will be there, no? Like this we have nowadays. Different designs will be there. So what you can do, you can take a rope and you can put a knot here like this and connect it like this and hold at one end and give a jerk. And what will happen to that jerk? By moving your arm up and down once. That's called like a jerk. I think by this time everyone knows how to generate a wave, how to generate a pulse. To generate a pulse, you have to just give a jerk like this. You move your arm up and down instantly. Then a pulse will be generated. If you move your arm continuously, then we'll get a sine wave. Got the idea? This one? So like this, now what I do is like I'm going to give a jerk. Due to jerk, a pulse will be generated. And in what direction the pulse will propagate here. Let's concentrate on this particular point P. What will happen to point P? Point P is like a knot that is put on a rope. Anything will happen to the grill. The point P is here. As the pulse arrives, this grill will move up and down. Possible? No, the grill will be fixed to the frame. No, so no question of this. Everyone able to understand? Because you may feel this is a very theoretical. Take a rope, tie it to plastic rope, tie it to some window, give a jerk and see, will this will move? I'm asking very simple question. Anybody? The point P, what is the point P? It's a knot. It's simple thing, knot. Now, will this knot, will it move or will it be at rest? Anybody wants to answer? Okay, some of you are asking, sir, what is the rope? How you are moving? Okay, take like this. What will happen to this knot? It's a very simple. You go to the terrace or somewhere in the very small vibration, no vibration, finish. It's a knot, no. Why all this? First, I want you to have practical idea. I think you are going to tie a rope between two walls to hang close. Am I right? To dry close. No, this is a knot. No, you're going to put knot. One nail will be there. To that nail open, you are going to tie this particular rope. Am I right? Or still, I think nowadays we have a facility where we will have like this. Huh? Am I right? Topic will get over within 5 minutes. First of all, we should know practically what happens. I think this is what the anger. Nowadays we have facility also. Here what we do, we are going to put a knot for this. It's a fixed here. It will not permit. Okay, the knot will make it not big. Yeah. And now, if you move this, will it move up and down? This anger, or this will call inch. This is a string. Not very tightly it has put. Will it move up and down this one? No, no. This will be fixed. No. These 2 points will be fixed. So now what we'll write it, point P1, P2, and the rope vibrates. P1 and P2 are fixed. What are P1, P2? They are knots. Agreed? This one? Fine. This what? Means whatever, like you just pull this rope and release, so a pulse is generated. The knots will not move. The same thing here also. Now this pulse will approach here. So finally what will happen? The pulse after some time will arrive here. What will happen? The pulse wanted to move towards right. Now there's a wall. No, will permit for the wave to move? No, it will not permit. And we know how to take the tension. The tension in the rope here will be like this. Am I right? The tension on this small element will be in this direction. So how the tension here on the point or on the wall, or what is the point P? It's a point of a rope which will be fixed on the wall. Anything will happen to point P. It's a wall is a rigid, no? Well, this wall will move up and down. I think it's a stupidity, no? We know that one. It will never happen. So what is the state of point P? Point P will not move. Now look at this. The tension in the rope here at this particular segment, it will try to pull the wall up. It will try to pull a point P on a wall up. But as there's a rigid wall, as there's a rigid wall, as it is a rigid wall, so what will happen? What do you mean by rigid? There won't be deformation under action of external force. Though a tension is acting, as this wall is a rigid, so the point P will not move. So what is the thing now? What is point P? Okay, this is a very important. So point P will not shift or will not move, will not get displaced here. So what will happen? Now look at the tension on this element, how it is acting. The tension on this small element is acting vertically down. The net force should be vertically down, and because of this, how do it will move? It will start moving vertically down. So what will happen to the pulse? Next, my question is, yes, the pulse, what will happen? Will be like this. Then finally it will become horizontal. And what will happen to point P? Point P will not at all move. Now we know what all the energy that is there will be in the form of potential and kinetic. Will agree? The total energy of a wave, in what form it will be? It will be in the form of potential plus kinetic. Agree this? And both will be in equal proportion. Okay, already we have discussed a triangular pulse, then sine wave. You can pick up any other shape also, you can work out. Fine. Okay, now what will happen next? After this, the rope, what happen, will start taking shape like this. And finally, what is the energy of the wave? U plus K, U equal to K. Okay, agree. This is what happens for the wave. When a wave approaches a rigid wall, it will get reflected. And what will happen to the shape of the pulse? It will get inverted. So why do it will get inverted? So there's a primary question what student should ask here. So why the pulse will get inverted in this way here? So I'll put once again. Now as there's a rigid point P is a rigid. Let me indicate on point P. No. Point P is a it's a point P is a like a on a rigid wall. So as it is on a rigid surface, so it should not undergo displacement and action of external force. The tension in the rope will try to pull it up, but as a rigid, it will not undergo displacement. Then the tension on these segments will be acting down. So therefore, the elements what happen will start moving down. And at one instant, the wave what happen, the rope what happen will be horizontal. So here what we notice is that here what we notice is this will be the particle speed. The particles what happen will have a speed here because we know it is at extreme when force the force net force will be towards mean position. This is the mean position, so it will start accelerating. Speed will increase, and finally, when it comes to mean position, all these points what happen will have kinetic energy. Now you look at this here. What is the potential energy on the rope here? Zero. Am I right? How you can say zero? Because potential energy is due to deformation. No? Can you remember yesterday's class slope? Because of slope, there'll be potential energy. Because of slope, there'll be kinetic energy. So what is the slope here? Slope is zero. So no potential energy here. So what is the potential energy of the rope here? Will be zero. Here potential energy. Where do that potential energy has gone? It got converted into the kinetic energy. The total energy on a rope is only kinetic because there's no deformation. You can check it. And why the kinetic energy? Kinetic energy because the particles will accelerate. When they come at mean position, they should have maximum speed. So the whole energy of the rope will be only kinetic here. I'll write it very clearly. Only kinetic energy. Here both potential as well as kinetic. Anyway, I'm writing it, no? These are very, very important. Here now again, and that will be in equal proportion. So like that, what will happen to wave? The wave pulse which has gone here will get reflected, will get inverted. Shall I say there's an erect? If you send an erect pulse, it will get inverted. This is a property of wave. So what actually happening? The wave is getting reflected by a rigid end. So what is a rigid end? Something like this, because this end is connected to rigid wall. So this will become a rigid end. So what is our concept? Reflection of a wave at rigid end. I'll take it out. This may not be, or I'll push it down. So our topic will be reflection of best example of rigid end. Best example of rigid end. Take a rope and connect to a wall. Hinge at one end of the rope, let it be connected to wall. So that will become now a rigid end. Now the wave which is arriving here, after reflection will get inverted and will move back. What will happen to frequency of wave will not change. What was the frequency f? The same frequency it will be there. The frequency will not change. So what will change now? Only the phase of a wave will change. So it was erect, it will get inverted. This is what happens here. Any doubts you have, you can ask me. Later on, I'll bring sinusoidal wave. If it comes get affected, what will happen? First, let's learn the basic concept. Anybody having doubt, please clarify it. You can try this at home. Hmm? This one. Okay, next part. How you have to connect a rope exactly where it will be like this. Huh? I think the knot will, this horizontal beam will not permit the knot to move. Therefore, the reflection at the rigid end. The point P will become now like a rigid end. So this will be inch or I'm giving several examples so that you will understand, okay, this is what you are learning. Okay, let me take the reflection at a free end.